do your homework tonight and then drop that picture in. Just don't hit submit. And, I can check the front of your worksheet, and then you can drop the other picture in later. If you want me to check it sooner. So today's the 4th. If you want to look at a function, know if it's a growth function versus decay function, it's all about the base of the power. So looking at that and saying, is that number bigger than 1 or is it less than 1? And so, looking at that first one, saying, of course, 1.3 is bigger than 1. So that's going to be a growth function. Okay. Looking at the next one, it's just the 3 that I'm looking at. Okay. The negative is not an issue. It's all about growth, bigger than 1 versus between 1 and 0. So that is still a growth function. It's just a reflected growth function. 4/7 is less than 1, so that's decay. 1 minus 0.2. Notice how that's inside the parentheses. So that is, the exponent is on all of that. Of course, 1 minus 0.2 is 0.8. So that'd be 0.8 to the x, which would be decay. 1 plus 0.05. It's inside the parentheses. The exponent's on that. So that'd be 1.05, which is bigger than 1. So that's growth. And that last one there, the 5 is there, the half is there, but only the half has the exponent on it. Only the half is the function. The 5 is a stretch. Okay, so that's a decay function. I'm only looking at the half. Okay? It's a stretched decay function. Okay? But still decay. So just watching out for those little things like that. It can be tricky on your eyes. Central question for today is, what does it mean for interest to compound? You're asking about what, Aiden?
About whether the number in front of the actual base affects it.
Okay.
There's okay.
Second. Get the roll taken real quick. All right, so exponential growth models, we're going to look at those. Compound interest, and then exponential decay and depreciation, we'll get that booklet tomorrow. Formulas are only as good as well as what the values within the formula are. All right, so even if we give you the formulas on the quiz, you still need to know what goes where and what does Y stand for, what does A stand for, so all that. So the first thing we're gonna do here is just kind of label things. So Y, or sometimes it can be P of T. These a lot have to do with population. Okay, so you might say population as a function of time, P of T, or you can just call it Y. But what that stands for is the population or the amount at a given time. Okay. It also could stand for just an amount of things. If you were looking at the growth of number of cherries on your cherry tree over time, you could talk about the amount of cherries on your, you could still instead of saying population, you could say amount at a given time. The A value there is the initial population or the initial amount. And when we say initial, we're talking about the starting thing. So when you look at this problem down here, that A value would be that 102 toads that the problem started with. Okay? So it's the initial amount or the initial population. R is the rate, the growth rate, or the rate of change. But it has to be as a decimal. And this really is the part that messes with people the most. This is by far the most common mistake with these types of problems, is people looking at that rate of change, but then not approaching it the right way. We talk about percents. Percents are a way we communicate, but we don't math with percents. We math with decimals. And so we have to take a percentage and turn it into a decimal before we can do any math with it. So if I have something like 17%, that's equal to 0.17. But we take something like 7%, and I can tell you how often I see something like 0.7, which is 70%. So it's not okay to do that. So it needs to be 0.07. Okay. You could also have like percents with decimals in them, like 1.35% would be 0.0135. Okay. So those numbers that are less than 10, you need to make sure they have that extra 0 in front of them. But again, by far, that is the most common mistake people make on these problems, is not dealing with R the right way. And then T is just time. Usually it's as years. It's not always with problems like these, but for what we're going to do, it's going to be in years. But it's not always. So I'll just say usually in years. Yeah. Yes, go ahead and just do decimals, and don't worry about fractions. It's going to be easiest because you're going to have to add it to 1. You won't want to add 1 to a fraction. You just want to add it to a decimal and make it easy on yourself. 1 plus 0.17 is 1.7. 1 plus 0.07 is 1.07. Don't turn them into fractions. One of the rare occasions I'll say that, right? So you guys need to know those values. Like, what does A represent? What does R represent? What does T represent? Because these are really reading problems, guys. They're not really math problems. You aren't going to be doing a lot of math. You're going to be plugging things in your calculator. That's it. Okay? You need to read the problem, read the situation, write the equation. It's really just plugging numbers into a formula, and then plug that into your calculator. Okay? It's more about reading than anything. So, this is a true situation, something that's actually happened. So way back in 1935, Australia brought these cane toads into their fields because they had these beetles that were eating their sugar cane, and sugar is life. So they brought these toads over from South America to eat the beetles, and but the toads have venomous skin, this secretion that comes out. So if anything tries to eat the toad, that thing dies. So they don't have natural predators in Australia, and so the populations have just gone absolutely insane. There's like a huge ecological issue because of all these toads. If you look up cane toads, Australia, it's a big thing. Okay? So in 1935, 102 toads, right? So what information are I given there? There's my starting information. There's my A value. Okay? Blah, 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 blah. Growing exponentially at a rate of 20% per year, right? What is that information? Right, there's my R value. And how many toads were there in 1955? How many toads were in 1985? So before we do anything else, what I have you guys do is have you write what's called a model equation. This is something I'm going to do with you guys today. It's something I'm expecting you guys to do on your homework, and it's something that's going to be expected on your quiz. Write this in a very specific way. Okay? What a model equation is going to look like is y equals, or p of t equals, we're going to take that A value, 102, plus, times 1 plus, we're going to take that R value, but R is a decimal, 20% as a decimal is 0.2 or 0.20. Okay, we don't need that second 0 if you don't want it. I don't usually write it. Okay. To the t. You are going to leave t as a t. This is the model equation. I want you guys to write this way. Okay. Every year I have students that skip past this. I'm not happy with that. What this allows us to do is then calculate this for any time, not just for the specific times that we have. So this is an equation that models the situation. We need that variable on that right side, that t value. Okay. I expect to see that from you guys, that model equation. Then I go back and say, hey, what about what's going on in 1955? So the first thing I have to worry about is how much time has passed. It's not an absolute time, it's a time change. Okay, well, from 1935 to 1955 is 20 years. So I say, okay, t is 20. Okay, so y equals 102. If you want to do this math right now and you want to say it's 1.2, you can. I usually don't. 1 plus 0.2, now to the 20th power. And you're going to type that in your calculator. Let's all get our calculators out. You're all going to type this. Now what am I doing there? Okay, so 102 parentheses 1 plus 0.2, those parentheses, caret 20. Okay. Make sure that what you typed, appears on the screen, that it looks right. All right, compare it to what you wrote. And then there's our answer, 3,910.435, 3,910.435. But Mr. Baker, you say, why would you write 0.435 of a toad? That makes no sense. I'd be like, you are quite right. So what you guys are going to do, you're going to use appropriate rounding and some sort of a word that says about, around, approximately. So we don't have a decimal of a toad, and so that 4 would round down. So about 3,910 toads. Okay, there's your answer. Some sort of approximation word, your correctly rounded answer, and then what are we talking about here? We're talking about toads. Okay, that's what I expect to see. You don't need to do this. I do want to see this. I don't want to see what you typed into your calculator. Okay, and at the very least see this. I don't need your decimal answer, and then this. So as far as things I want to see, at the very minimum, those 3 things. Okay, I can see what your t-value was right there. I can see what you got for your answer. That's enough for me. Okay. Next part of that problem, 1985. Okay, you do not go to the 55. Okay, that's you plugged it in, it's done. You go back to the beginning of the problem for time change. The 102 came from 1935, so we have to go all the way back there if we're going to do this problem. So from 1935 to 1985 is 50 years. So you'd say y equals 102, 1 plus 0.2 to the 50th. Go to your calculator. If you have a TI-83, TI-84, really actually any TI, even if it's a TI-30, okay, whatever. If you hit second enter, I don't know if you guys can see this or not. All right, if you just hit second enter, so there's my answer for the last one. If I hit second enter, it'll bring up the last thing I typed. Doesn't bring my answer. Second enter, bring it, and then I can go and edit that 20 to be a 50. I hit over, and I change that 2 to a 5. Just hit 5. All right. Okay, then I hit enter again. I don't have to retype everything. Okay, I can just edit it. It works the same way on the app. If I tap that up there, I go and I change the 20 to a 50. I don't have to retype the whole thing. Okay, so work smarter here. So 50 years, 928,245. Right, appropriate rounding. Round that up. 928,245. I'm going to use an approximation word. So around 928,245 toads. Again, that'd be the minimum I want to see from you guys. What did you type in your calculator? What did you get? You don't need to give me that. Does that make sense? Want you guys to try next one? Yep. I want a model equation. This thing right here. And then you guys have 3 things here to do. Give you a couple minutes to do that. We might run into the tornado drill here real quick while we're working on this, but for the couple of us that are here in the building. I want you guys to write a model equation and then do the 3 time values here, just like we did. So model equation and then 2 answers, or I guess you guys have 3 answers. Sorry, hold on. Anytime you borrow money, so like if you take out a loan, you have a credit card, anytime you invest money like into a savings account or other types of investment, like a CD or something like that, they use what's called compound interest. So essentially what simple interest was, imagine if you put in $1,000 into a savings account that gave 10% interest, which would never happen. It's way too high. But after a year of simple interest, they would give you that $1,000 back plus the 10%, which is $100. Okay, so you get $1,100 back. What compound interest does is, if it's basically what it does is it compound, like you get the interest more often. So sometimes you can hear about like interest being compounded monthly. So if we instead invested our money into an account that gave us 10% back but compounded monthly, what would happen would that they would take that $10,000 or that $1,000, sorry, and you wouldn't get 10% of it every month, but you'd get a 1/12 of that 10% every month. Since it's 10% is an annual interest rate. Anytime you guys ever see the phrase APR, that's the annual percentage rate. All right? If you pay like a credit card, you might have like a 17% APR. That does not mean you pay 17% of your credit card bill every month. So you get a 1/12 of that every month. So if we have a 10% rate, that'd be 0.1. And we divide that by 12, that's how much like percentage interest we would get each month. Times that by 1,000, I would get $8 that first month. Now all of a sudden, instead of having $1,000, I have $1,008.33, right? Well, the next month, I get that same 1/12 of 10% on my account. And so the next month I earn $8.40 worth of interest because my earned interest. Notice how the interest went up. First month I earned $8.33. Next month I earned $8.40. And then that would get added to my account. And then the next month I would earn interest on my interest. Okay? Compound interest is when your interest also earns interest. Okay? The money gets added into that. That's why it's called compound. Just like in chemistry, what a compound is when things are added together. Okay? So it's still just a formula. Okay? It's a growth formula. So you notice it's pretty much the same, like in structure, as the last formula we did, right? Something equals a number times 1 plus something, all to the something power. It's just we have this n now, and then some of the letters have changed a little bit. Because it's specifically for money, the letters just have certain names now. Like that A stands for the final amount or the amount at a given time. Usually we think of it as the final amount, but we could also think of it as amount at a given time. It's the amount of money. It's not a population. It's always about money. P doesn't stand for population anymore. It stands for principal. You take out a loan, so if you had a $15,000 car loan, your principal would be that $15,000. If you put $2,000 into a savings account, the principal is that $2,000. So the principal is the initial amount, the starting amount. So just like the last one, right? We have an ending amount, we have a starting amount. R is what R is. But here it's the interest rate, not a growth rate, but the interest rate. It's the same thing. It still needs to be as a decimal. Again, that is still the number one mistake people make. It's not changing that to a decimal appropriately. T, still time. And with this money stuff, it's always in years. With the population stuff, sometimes it could be in days or hours. Like if you're looking at populations of bacteria, you wouldn't want to look at those over years. You'd want to look at them over like an hour or a day. But with money, it's always going to be in years. And then N. So N's our new thing here. What does N stand for? So n is the number of times per year that the interest gets compounded. Like I was talking about it getting compounded monthly, 12 times a year. So we use the letter n because it stands for the number of times per year. Okay? Interest is compounded. Why I'm underlining that is because mistakes I've seen in the past with this, if you imagine your interest was compounded twice a year and then you were looking over 10 years. I've had students take that 10 and that 2 and multiply them and get 20 and make their end value 20. Okay? This is the number of times per year it's being compounded. So if it's compounding twice a year, my end value is 2. The 10 times the 2 will happen up here on its own. You don't need to do that down here. Okay, that should be a 2, that should be a 2. If that was a 10, then it would be 10, and they multiply. Okay? So just look at the per year. So when you look at one of these problems, you'll notice that it looks pretty similar to what we just saw. You deposit $5,500. Oh, look, there's my principal, my initial amount. It pays a rate of 3.6%. Ooh, there's my rate, right? There's that. Find the balance after 2 years. Okay, there's my time. Okay, oh, there's T. And if the interest is compounded semi-annually or daily. I still have a letter, but I don't have any more numbers. What's going on there? Okay. When we talk about end values, they always come to you as a word. They do not come to you as a number. The principal will come to you as a number. The rate will come to you as a number. The time will come to you as a number. N will always come to you as a word. You need to translate that into a number. They have set values. Most of this should be common sense. Okay? They may not be something you're super familiar with, but they should make sense when we look at them. Okay, so we're going to do a quick little table over here of n values. And you guys will need to know these. We will give you guys the formulas on the test. We will not give you these. You guys need to know these. Again, they should be pretty much common sense. So if something happens annually, that means it happens once a year. That means n would be 1. We're going to have like 7 of these maybe, so just watch your spacing. Okay? Semi-annually. Semi-annual means it happens every half year. Semi means half. If something happens every half year, that means it happens twice per year. When you're working in the business world, quarters are mentioned quite often. So we would use the term quarterly. So if something happens quarterly, just like there's 4 quarters in a dollar, just like there's 4 quarters in a football game, something happens quarterly, it happens 4 times a year. I mentioned earlier monthly. Right, something happens every month, that means it's happening 12 times per year. You could also look at weekly. You should know how many weeks there are in a year. And last one here would be daily. If your interest is compounded daily, you should know how many days there are in a year. Even if it's a leap year, it's still calculated as 365. It was decided, a long time ago that that's the number, that's it. It doesn't change because the year is a little bit longer. Okay? So those are things you guys will need to study at some point if just working with them, or if that doesn't seem common sense enough. Okay? Hopefully it does seem fairly common sense. But those words will pop up in the problem. You need to say, oh, it says weekly. I better use 52 here. Okay? That's the way that's going to play out. So, the way I've set up these problems, we've already done part A or step 1 there. We're just going to do step 2, but notice how it's broken down in an A and a B. So we're going to do this calculation for semi-annually, then we're going to do the calculation for daily. The problems will be almost exactly the same, except for one number will change. If we want to, we can write that down again. P equals 5,500. That's our principal. are, I'm going to go ahead and translate that to a decimal now, 0.036. T is 2, and N is also 2. So unfortunately, we have two 2's here, but we'll figure it out. So A equals 5,500, 1 plus 0.036 divided by the purple 2, not the blue 2, okay, all to the 2 times 2 power. So you guys certainly can feel free to do that multiplication there in your head, add 2 times 2. If you're not going to do that, and sometimes you won't want to do that because the next one we're going to do is going to have an n value of 365. We're not going to want to do that multiplication in our head. What you need to do instead, when you go to type this in your calculator, you need to put parentheses around that exponent, okay? Or else it will mess up. So if you're not going to do that multiplication in your head, you do need to put that there. Okay, so as I go to type that, 55. Other than that, it should look exactly the way we just wrote it. 5,500. You guys should all be practicing this. Just get that little bit of muscle memory down. Plus 0.036 divided by 2. Caret parentheses 2 times 2. Close my parentheses. Hit enter. Ooh, I hit the wrong button. Enter. There's my answer. Okay. If I hadn't put those parentheses there, see how different the answer is. And look what it did over there on the left. Look, it's telling me what it did. And I notice how that second 2 dropped down. That's not what I wanted it to do. That's what's really good about having a good scientific calculator. It'll tell you what it did. It'll say, here's what you typed. Well, here's what I did. Because you talked to me wrong. Right? That's your fault. Okay? So make sure you're typing it correctly. It's money. Money has cents, right? So we should always have 2 decimal places for our rounding for money. So $5,906.82. So again, I expect you guys to do appropriate rounding. I expect you guys to have a dollar sign there. What was it? I don't know what this is. I'm sure if I remember right. 5,906. So there's your answer. Part B here, we're just going to the other n value. So everything else will be the same. N is now 365 for daily. So it'll be A equals 5500 times 1 plus 0.036 over 365. So change that. And you're also going to change the 365. Still going to be multiplied by 2, though, because it's still 2 years. Okay? Everything else stayed the same, right? Again, you're going to want those parentheses. You're really going to want those now, right? You're not going to want to do that in your head. You can hit your second enter button on your other one, on your TI. Bring up that other thing. Okay? There is some little tricks here when you have bigger numbers you're putting in, like longer numbers you're putting in. It's not quite, doesn't play super well, but it is doable as far as editing. On the app, I just tap it, go and I can click over by the 2, delete the 2, put 365 in there, hit that 2, 365 in there. Okay. If you want to know like some of the little tricks with the TIs, like how to do that quickly, that's something you just need to talk to me about. Okay. And I've been using this since I was, y'all's age, so I know how to do that easily. Okay. $5,910.58. These numbers, guys, should always be very close to each other. Okay? If you get 2 way different numbers, you're doing something wrong. All we're changing is the compounding periods. That just changes things a little bit. But you can see that the more often you compound, the more money you end up with. It's not a lot more money, but it's more. And the longer you wait, this is only over 2 years. If we extended this like 20 years, that's just going to get bigger and bigger. Okay, the difference there. So 5,910 and 58 cents. I don't need you guys to use like an around or about or anything like that. It's assumed that there's rounding here because. Okay. But yeah. Why don't you guys at least do one of those down there? Make sure you're doing it right. Over here. All right, here's what you guys should have gotten. Completed one of them. Anything feeling weird? What you guys are doing? Good? You good, Jubal? You good, Mason? So you guys should be good to go on the front of that worksheet. Again, if you want to do that tonight and post that and let me check on that for you tomorrow, I certainly can. We'll do that last page of the notes tomorrow, and you guys will then have the wherewithal to do the back of the worksheet. Okay. But tomorrow should be pretty easy. We don't have much to do. So,
Mr. Baker, can you scroll up really fast?
Sweetly. Is that enough?
A little higher. Okay, that's good. Thank you.
Mm-hmm.